Good evening, everybody. Let me start. Is it audible?
Audible, sir.
Yeah. Fine. In the last class, we have discussed about the step response of an RL circuit. Okay. So let me revise the things which we have discussed in the last class. Okay. First, we have discussed about circuit elements. We have circuit elements, voltage source. This is the ideal voltage source. Whereas this is practical voltage source. This is the representation of ideal voltage source. Whereas this is the representation of practical voltage source. This is the representation of ideal current source. This is the representation of practical current source. You know, right? This represents interrelation of this voltage source. Okay, here the interrelation is 0 in case of ideal voltage source. Whereas here, interrelations of ideal current source is infinite. Okay, this is the interrelations of practical current source. Okay. We have circuit element, voltage source, current source, resistor. Apart from resistor, we have two more elements: inductor and capacitor. Okay, this is the element which consumes energy. Okay, which dissipates energy in the form of heat. Okay, so whereas in case of these two elements, okay, these two parameters do not consume any energy, and these two parameters store energy. Okay, this element stores energy in the form of electromagnetic energy, whereas this element stores energy in the form of electrostatic energy. Coming to voltage current relationship of this resistor is V is equal to IR. Okay, whereas voltage current relationship of the inductor is V is equal to L dI by dt. Voltage current relationship of the capacitor is I is equal to C dB by dt. You know, V is equal to IR in case of resistor resistive circuit. If I apply voltage across this resistor, let I is the current flowing through this, R is the resistance of this resistor. Then because of this relationship, current flowing through this resistor, this current waveform follows the input waveform, where V is the voltage which is applied across the resistor, I is the current which is flowing through this resistor. Okay, then current waveform follows the voltage waveform because of this relationship. V is equal to IR. Okay, because of this relationship, current follows the voltage waveform. Okay. So already we have discussed about this, right? Okay, so for t less than 0, V is equal to 0. Okay, this portion is for t less than 0. Okay, this portion is for t greater than 0. Okay, this instant is t is equal to 0. This instant is t is equal to 0 minus. Just before the change of voltage, that instant is called t is equal to 0 minus instant. Okay, t is equal to 0 plus instant. Okay, just after the change of voltage is called t is equal to 0 plus instant. Okay, right? For t less than 0, voltage is 0, no voltage is there. Right? At t is equal to 0 minus, just before the change of voltage, means this instant, V is 0. If you are applying voltage at t is equal to 0, so at t is equal to 0 minus, voltage will be 0. At t is equal to 0, V is jumping from 0 to V. Okay. One cannot say 0 volts or V volts. Okay. It is jumping from 0 to V. At t is equal to 0 plus, V is equal to V. Okay, that is just after the change of voltage. This instant, V is equal to 0 plus is the instant just after the change of voltage. Instant. For t greater than 0 means this portion. T greater than 0, V is 0. Already we have discussed in the previous lecture, right? Okay. Whereas coming to this I, okay, same. For t less than 0, it is 0. T is equal to 0 minus is 0. T is equal to 0, it is changing from 0 to I. T is equal to 0 plus I is equal to I. For t greater than 0, I is equal to I. Okay, that is for t less than 0, if voltage is 0 means current is 0. If t is equal to 0 minus voltage is 0 means current is 0. T is equal to 0, voltage is jumping from 0 to V means current is jumping from 0 to I. If t is equal to 0 plus voltage is V means I is I. For t greater than 0, voltage V means I is I, means current waveform is following the voltage waveform. Just we have the multiplication factor of R. Okay, that's why as we have the because of this relationship in case of resistor, okay, current waveform follows the voltage wave. In case of inductive circuit, it is not like that. Okay? Because the voltage current resistance for the inductor is not like V is equal to some constant into I. Okay? It is V is equal to L dI by dt. Because of that relationship, current waveform doesn't follow applied voltage waveform. Okay, we know, right? An inductor is an electrical component that opposes any change in current. Okay? Already we made this statement in the previous lecture. We have discussed about this statement, right? Okay, that is the current flowing through the inductor cannot change instantaneously. Okay. So this instant is t is equal to 0 instant, 0. Whereas this instant is t is equal to 0 minus instant. This instant is t is equal to 0 plus instant. Okay, so here the current flowing through the inductor cannot change instantaneously. Instantaneously means, okay, within 0 time current doesn't change. Means whatever the current is available at t is equal to 0 minus, same current will be available at t is equal to 0 plus. Okay, time from 0 minus to 0 plus is almost 0 time, and within that 0 time current doesn't change. Current doesn't change means whatever the current is available at t is equal to 0 minus, that current will be equal to the instant where, that current is equal to I of 0 plus. Okay, that is current at t is equal to 0 minus is equal to current at t is equal to 0 plus. Means I of 0 minus is equal to I of 0 plus. Okay, just write before the change of current, just write after the change of current. Okay, already we have discussed about this statement, right? Okay, that is within 0 time current doesn't change in case of inductor, right? So I can write like this: I of 0 minus is equal to I of 0 plus. Whereas in case of resistor, it is not like that. I of 0 minus is not equal to I of 0 plus because of that relationship, V is equal to IR relationship. Because of V is equal to LDI by dt relationship, okay, I of 0 minus is equal to I of 0 plus. Already we have discussed about this. Okay, why the current to the inductor cannot change. Okay, I have justified that statement in the previous lecture, right? Okay, so next one. Okay, this is justification of that statement. Okay, you can justify the statement by making the statement like this. By here, if the current changes, right? Already we have discussed it. Okay, to bring about such a change, I have to apply infinite amount of voltage. Right? V is equal to L d I by dt. Okay, if current is changing within 0 time, means the voltage becomes infinity. So we have to apply, if I apply infinite amount of voltage across inductor, then only current to the inductor can change instantaneously. So this is impossible. Okay, in practical, we apply finite voltage. The current to the inductor cannot change instantaneously. That is one of the properties of the inductor. Okay, coming to the second properties of the inductor. Just a minute. The voltage across inductor is not proportional to, right? V is equal to L dI by dt. It is not proportional to current. It is proportional to rate of change in current. Okay. Next, one more statement. Okay. V is equal to, V is equal to LdA by dt. What is the discussion about this, right? So if current is constant, with respect to time, then voltage becomes zero. If this is constant, current is constant, means dA by dt will become zero. Means voltage becomes zero. If voltage across the inductor is zero, means that inductor acts as short circuit. That inductor acts as short circuit. So you can make statement like this. Okay? The inductor acts as short circuit under steady state DC current. Under steady state DC current, the inductor acts as short circuit. Steady state means when time approaches infinity. When time approaches infinity, inductor acts as short circuit. Okay, this will happen. This inductor will act as short circuit when time approaches infinity. Okay, initially it doesn't act as short circuit. Okay, later point of time means when time approaches infinity, it acts as short circuit. Okay, this statement is true at steady state. Okay, inductor acts as short circuit when time approaches infinity. Okay, this statement is true at steady state. Okay, that's why the inductor acts as short circuit under steady state DC current. Okay, under steady state DC current. Okay, means when time approaches infinity, the inductor acts as short circuit. Okay. This is the representation of real inductor, real or practical inductor. Okay, step response of an RL circuit. Okay, what is the step response? Okay, after applying KVL, the T is equal to 0, we are closing the switch. Okay, then you can apply KVL around this switch. Again, you get that equation where Vs is applied voltage. Okay, complete response of the system is composed of two responses. Okay, one is this is what natural response, whereas this is forced response. Already we have discussed about this, right? Okay, natural response or transient response. Natural response or transient response. Natural response plus forced response. Transient response plus steady state response. Right? Aim is natural response. Forced. Yeah, find alpha. Okay. From homogeneous situation, you can find alpha. Okay, by using initial conditions, you can find constant. You can find V1 by using initial conditions. Okay. I of here, I of 0 minus is equal to I of 0 plus is equal to I of 0 is equal to 0. Initially current is 0. As this is uncharged inductor. We finally will have the expression. This is for t greater than 0, with 0 initial condition. Means I of 0 minus is equal to I of this one. I of 0 plus is equal to I of 0 is equal to 0. With 0 initial condition. With 0 initial condition. We place uncharged inductor in circuit. Then we'll get the question like this. discuss this problem. Find I of t in the circuit below for t greater than 0. For t greater than 0. Okay. First of all, we have to find initial value. Initial value. T at t is equal to 0. The switch is opened. The switch is opened. Okay. Meaning of this is the switch is opened. Opened at t is equal to 0. See, when the switch is opened at t is equal to 0 means switch has been closed for a long time. Before the switch is closed. Sorry, before the switch is opened. Before the switch is opened, it has been closed. It has been closed for a long time. Means for t less than 0, it has been closed. It has been closed. Because see, we are opening the switch at t equals 0 means already it has been closed. Okay. So once you open the switch means for t greater than 0, it will be open only. Okay. So meaning of we are opening the switch at t equals 0 means already the switch has been closed for a long time. The switch has been closed for a long time. Means for t less than 0, see here this instant is t is equal to 0 instant. Okay, this instant. Okay, here you are opening the switch. You are opening the switch at t is equal to 0. You are opening the switch at t is equal to 0 means already the switch has been closed. The switch has been closed for a long time. For a long time, already the switch has been closed. Means for t less than 0, the switch has been closed. Okay. Once you open the switch at t is equal to 0 means it will be opened only, right? Okay. Right. For t greater than 0, also it is opened. Okay. This is the position of it, right? This instant is t is equal to 0 minus. Okay. This instant is t is equal to 0 plus. Means the instant see at this instant you are opening the switch. Okay. This instant just before the switch is open. Okay. The instant where just before the switch is open is t is equal to 0 minus. The instant where just after the switch is open is t is equal to 0 plus. Okay. So you are going to find I of t for t greater than 0. You are going to find the expression for t greater than 0 means I should find, first of all, I should find initial condition. Initial condition means I have to find I of 0 minus. I of 0 minus. I have to find I of 0 minus. Okay. Because a t is equal to 0 minus, for t less than 0, a t is equal to 0 minus, steady state occurs. Okay. We have two responses, right? Okay. Transient response plus steady state response for t less than 0. For t greater than 0 also, transient response, steady state response. Okay. For t less than 0, steady state occurs at t is equal to 0 minus. For t greater than 0, steady state occurs when time approaches infinity. When time approaches infinity. Okay. So for t less than 0, the circuit would be different. For t greater than 0, the circuit would be different. Okay, we have two circuits. Okay, before opening the switch, after opening the switch, we are going to have two circuits. Okay, for two circuits, you are going to have two transient responses, two steady state responses. Okay, so but here for t less than 0, you will not bother about this. No need to bother about this transient response. We will not consider this transient response because always we take steady state response. Okay, because here the initial condition is taking place at steady state. Okay, steady state occurs at t is equal to 0 minus. So this will be initial condition. You see, you are going to have I of 0 minus. You are going to get I of 0 minus. Okay, steady state occurs at t is equal to 0 minus. So you need to find I of 0 minus. You need to find transient response for t less than 0. Okay, so you should find I of 0 minus, and this will occur at t is equal to 0 minus. Right? Okay. Now, right? current to the inductor cannot change instantaneously. Means within 0 time, current doesn't change in the inductor. Okay. So I of 0 minus is equal to I of 0 plus. Okay. From t is equal to 0 minus to t is equal to 0 plus, current to the inductor doesn't change. So within 0 time, current doesn't change. Which is equal to I of 0. Which is equal to I of 0. Okay. So whatever the current is available at t is equal to 0 minus, same current will be available at t is equal to 0 plus. So I of 0 minus equal to I of 0 plus is equal to I of 0. Okay. You should find this. So you find I of 0 minus. So in order to find I of 0 minus, okay, you need to draw the circuit at t is equal to 0 minus. If t is equal to 0 minus, what will be the circuit? If t is equal to 0 minus, 10 volts, 2 ohms, 3 ohms, 6 has been closed for a long time. Means at t is equal to 0 minus, which is closed. Which was in closed position. Right? At t is equal to 0 minus, steady state occurs. At steady state, inductor acts as short circuit. The current which is flowing to this, the current which is flowing to this is, the current which is flowing to this at t is equal to 0 minus is I of 0 minus. I of 0 minus. I of 0 minus, right? Okay. So 10 by 2, you're going to get 5 amps. Means I of 0 minus is equal to I of 0 plus is equal to I of 0 is equal to 5 amps. This is the initial condition. Okay. With the help of this initial condition, that is I of 0 minus, you can find I of t for t greater than 0. So t is equal to 0 minus, we got initial value I of 0 minus equal to 5 amps. Okay. Current to the inductor cannot change instantaneously. That's why I of 0 is equal to I of 0 minus equal to I of 0 plus is equal to 5 amps. Okay. Now, in order to find I of t for t greater than 0, let us have the circuit. Let us have the circuit for t greater than 0. Okay, you are opening for t greater than 0. For t greater than 0, what will be the circuit? You are opening at t is equal to 0 means for t greater than 0, the switch is open. Means the circuit would be like this. The circuit would be like this. For t greater than 0, you can add 2 resistances as they are connected into 5 ohms. Okay, this is 1 by 3 Henry. This is how much is 10 volts. Okay, so this is the circuit. You have to find I of t for t greater than 0. Okay, so you have to find final value, that is I of infinity. Okay, steady state occurs at t is equal to infinity, right? Okay, let us find steady state value. Steady state value is I of infinity. At t is equal to infinity. Okay, at t is equal to infinity, what will be the circuit? But at t is equal to infinity, the circuit would be like this. 5 ohm. Inductor acts as short circuit. At t is equal to infinity, inductor acts as short circuit. I of infinity. You have to find I of infinity. Okay, at steady state occurs. Steady state occurs at t is equal to infinity. For t greater than 0. For t less than 0, steady state occurs at t is equal to 0 minus. Okay, so let us find I of infinity, which is equal to 10 by 2 plus 3 is equal to 2 amps. I of infinity. We have initial value and final value. Okay, let us find time constant. Time constant tau. Time constant tau. Tau is equal to L by R. For t greater than 0. For t greater than 0, you have to find time constant. Okay, you know the value of inductor, you know the value of resistance. Okay, you can find time constant. Tau is equal to L by RTH. Okay, RTH. L by RTH. Okay. by using this formula, we can have the expression current for t greater than 0. Okay. Otherwise, you can also solve the problem like this. Okay, I of t is equal to, okay, right, a1 e power minus t by tau plus a, which is equal to a1, e power, after using this time constant, we're going to have minus 15t plus, this is nothing but what? I of infinity, steady state value, is steady state value. Okay, so I of t is equal to, this is what? Transient response. This is steady state response. It is composed of two parts. Okay, transient response, steady state response. Okay, you know the value of I of infinity. Okay, already we have got this value, right? Because this value I of infinity is 2 amps. Okay, so this is 2 amps. 2 amps plus e power minus 15 t a1 is equal to I of t. Find a1 using initial condition. If you use initial condition, means I of 0 is equal to a1 e power minus 15 into 0 is equal to 1 plus 2. You know what is initial value? 5 is equal to a1 plus 2. What is the value of a1? 3. Okay, finally you get 2 plus 3 into e power minus 15t for t greater than 0. Either you use formula like this, otherwise you can also solve the problem like this. Okay, next problem. Okay, here shows the plot of current I of t through series RL circuit when a constant forcing function of magnitude Vs is applied. Okay, that is RL circuit, series RL circuit. Okay, forcing function applied across series RL circuit is 50 volts. Okay, this is 50 volts. Okay, this is R, whereas this is L. Right? Calculate the values of R and L. Calculate the values of R and L. Okay. So here, this is steady state value. Okay. This is the final value. Okay. Total response is composed of two parts. Okay. This is transient response and this is steady state response for t greater than 0. Okay. Steady state occurs when time approaches infinity. For t greater than 0. For t greater than 0. Okay. So at steady state, inductor acts as short circuit. Inductor acts as short circuit. Inductor acts as short circuit. Right. So when it is acting as short circuit, okay, that is I of infinity. It acts as short circuit. When it is acting as short circuit, the current flowing through the circuit would be V by R. Okay. So you know at steady state, what is the current in the graph? 10 amps. 10 is equal to forcing function is 50, applied voltage is 50 R. So that you can find R is equal to 5 ohms. R is equal to 5 ohms. Okay. Now here, final value is 10 amps. This is 6.32 amps. Okay, 6.32 amps at t is equal to 0.3 seconds. 0.3 seconds means, okay, this will be time constant now because it is a time taken by the response to reach 63.2% of its final value. It is 63.2% of its final value. So the time constant would be 0.3. Okay, tau is equal to 0.3. Okay, tau is equal to what? L by R is equal to 0.3. get the value of L. Now, let us go for the problem.
Sir, ఇందాక ప్రాబ్లం మళ్ళీ పెట్టారా?
Okay, fine. Then the key here. I'll do one thing.
ఓకే సార్. సార్ నెక్స్ట్ చెప్పండి, ఇదేం రబ్ చేయకండి.
You asked me to explain again, right?
నో సార్, అంటే క్వశ్చన్ చూద్దామని మళ్ళీ పెట్టమన్నా.
Okay. Is this fine now?
ఎస్ సార్, ఫైన్.
Okay. I'll go for next problem. If you want me to discuss it again, I'll discuss. No problem.
ఓకే సార్.
Okay, fine. Yeah. Actually, see here. This is RL circuit. RL circuit. Okay. Forcing function is means applied voltage 50 volts. Applied voltage 50 volts. Okay. RL, right? Okay. So here 10 amps is steady state value. Okay. This is the response. This is the response for RL circuit. Okay. This is transient response, whereas this is steady state response. Okay. As it is reaching, current to inductor is reaching final value here. Current to inductor is reaching final value here. Okay. So steady state occurs at t is equal to infinity. For t greater than 0, this is the response for t greater than 0. Okay. For t greater than 0, steady state occurs at t is equal to infinity. When time approaches infinity, steady state occurs. Okay. So at t is equal to infinity, inductor acts as short circuit. Okay. Then circuit at t is equal to infinity. At t is equal to infinity, the circuit would be like this. If inductor is acting as short circuit, then circuit would be like this. Okay. Then what will be I of infinity? I of infinity is equal to V by R. Okay. So I of infinity is 10 amps. Steady state value is 10 amps. Okay. Because finally this current reaches 10 amps. Okay. So 10 is equal to 50 by R. Okay. From this R is equal to 5 ohms. 5 ohms, right? Okay. So here final value is 10 amps, and here this value is 6.32, means it is 63.2% of its final value. Okay. At t is equal to 0.3 seconds. It means this will be time constant of the circuit. Okay. So tau is equal to 0.3. Okay. Tau is equal to L by R. Okay. Substituting in the value of R, we can have the value of the next one. Okay. Here, for the circuit shown in the figure, the switch S has been closed for a long time. For a long time, then opens at t equal to 0. Okay. By seeing this circuit also, we will come to know the switch is opened at t is equal to 0. At t is equal to 0, switch is opened. Okay. Here. I'll add one slide. Okay, this instant is t is equal to 0. Okay, this is for t less than 0. This is for, this portion is for t greater than 0. Okay, here see, here opening the switch at t is equal to 0. You are opening the switch at t is equal to 0. You are opening the switch at t is equal to 0 means the switch has been closed for a long time. Closed into no open is, okay, so the switch has been closed for a long time. Then only you can open the switch at t is equal to 0. Okay, uh, by looking at the position of the switch. Okay, the switch is opened at t is equal to 0. Okay, switch is open. Switch is open at t is equal, once you open the switch means for t greater than 0, switch will be open. It will be open. Okay, here this instant, just before the switch is open, just before the switch is open, that instant is t is equal to 0 minus. Just after the switch is open, that instant is t is equal to 0 plus 0 plus. Okay, but t less than 0, steady state occurs at t is equal to 0 minus. This will be the final value for t less than 0. For t less than 0, this will be the final value. Final value. Okay, for t greater than 0, this will be initial value for this. Okay, because this value would be equal to this value. Okay, steady state occurs at t is equal to 0 minus. At steady state, inductor acts as short circuit. Inductor acts as short circuit. Okay, similarly, for t greater than 0, steady state occurs when time approaches infinity. So steady state occurs here for t greater than 0. Here inductor acts as short circuit. Inductor acts as short circuit. Short circuit when time approaches infinity for t greater than 0. For t greater than 0. Okay, this instant is just before the switch is open. This instant is just after the switch is open. Just after the switch is open. Okay, you know the property of inductor. Current to the inductor cannot change instantaneously, means within 0 time current doesn't change, means whatever the current is available at t is equal to 0 minus, same current will be available at t is equal to 0 plus, means I of il of we can say il of 0 minus is equal to il of 0 plus, which is equal to I of 0. Because see, I of 0 minus equal to I of 0 means which is equal to this or not. Okay, so this current is equal to this, means both will be equal to this current. Both currents will be equal to at this current at this instant. Okay, so I of 0 minus equal to I of 0 plus, because current to the inductor cannot change instantaneously. I of 0 minus equal to I of 0 plus is equal to I of 0. I of 0. Okay, so we should find this initial value in order to find the value of current for t greater than 0. Okay, so first let us find, okay, actually here we have to find VAB of 0 minus, IX of 0 minus, IL of 0 minus. So let us find one by one. Okay, first let us find VAB of 0 minus. VAB of 0 minus means VAB. VAB means voltage across inductor at t is equal to 0 minus. So at t is equal to 0 minus, what will be the circuit? At t is equal to 0 minus, what will be the circuit? Okay, the circuit will be like this. At t is equal to 0, what is the position of the switch? What is the position of the switch? Switch is closed. Switch is closed because the switch is opened at t is equal to 0. Means at t is equal to 0 minus, switch is closed. At t is equal to 0 minus, switch is closed. It's closed. Okay, switch is closed. It's closed. Okay, switch is closed. Switch is closed. And what about the inductor? Okay, at t is equal to 0 minus, steady state occurs. Inductor acts as short circuit at steady state. At t is equal to 0 minus, steady state occurs for t less than 0. Okay, so inductor acts as short circuit. Okay, So voltage at this point with respect to this point is VAB of 0 minus. The current flowing to this is IL of 0 minus. IL of 0 minus. The current flowing to this is IX of 0 minus. Okay, this is 5 ohms. This is 10. This is 6 ohms. Okay. Now what is VAB of 0 minus? VAB of 0 minus is 0. Okay. VAB of 0 minus is 0 volts. Okay. Coming to the second one. Second one. This is equal to 0 because it is short circuit. Okay. Coming to Ix of 0 minus. I should find this value. Ix of 0 minus. Okay. See, this is 20 volts. I think 20 volts, right? Okay. So this potential is equal to this potential. This potential is equal to this potential. Okay. This potential is equal to this potential. Same here, same potential equal to this potential. Means what is the voltage across 5 ohm resistor? Voltage across this 5 ohm resistor is 20 volts. 20 volts. You can find Ix of 0 minus. Ix of 0 minus is equal to 20 by 5. 20 by 5. This is equal to how much is it? 4 amps. 4 amps. Okay, next, third one. Third one is what? IL of 0 minus. What is the current flowing to this? IL of 0 minus. Okay. This current is equal to current flowing to this plus current flowing to this. Okay, let this is I1 of 0 minus. 0 minus. Okay, so third one is IL of 0 minus is equal to I1 of 0 minus plus Ix of 0 minus, which is equal to what is I1 of 0 minus? This potential is equal to this potential. This potential is equal to this potential equal to this potential equal to this potential equal to this potential. Means voltage across this would be again 20 volts only. Again 20 volts only. It is short circuited. This resistor is short circuited. Short circuited. Okay. So no current flows in this system. Okay then. 20 by 10 plus 4 is equal to 6 amps. 6 amps. Okay, I of 0 minus is 6 amps. Okay, now coming to Ix of 0 plus. Ix of 0 plus. Okay. If T is equal to 0 plus, what will be the circuit? If T is equal to 0 plus, 20 volts. If T is equal to 0 plus, it is opened. It is opened because it is opened at T is equal to 0. It is opened at T is equal to 0 means this will be opened at T is equal to 0 plus. Okay, this is open now. Okay, now the current flowing to this is Ix of 0 plus. This is the circuit at T is equal to 0 plus. This is circuit at T is equal to 0 plus. Okay, I think this is 6, this is 10, this is 5. This is 1 individual. Yeah, 1. Okay. So Ix of 0 plus. Here Ix of 0 plus is equal to IL of 0 plus. IL of 0 plus. current flowing through that resistance is equal to current flowing through that inductor here at t is equal to 0 plus. T is equal to 0 plus, the circuit would be like this. Okay, at t is equal to 0 plus, current flowing through this is equal to current flowing through this as they are connected with this. Okay, let us find IL of 0 plus. Okay, current to the inductor cannot change instantaneously. That's why IL of 0 minus is equal to IL of 0 plus, which is equal to IL of 0, which is equal to 6 amps. Already we found this value, 6 amps. Then Ix of 0 plus would be 6 amps only. Ix of 0 plus would be 6 amps. Okay. Next we have to find VAB of 0 plus. VAB of 0 plus, right? Okay. You apply KVL around this loop. Minus 20 plus 5 into 6, because current flowing to this is 6. Ix of 0 plus into 5. Ix of 0 plus into 5 plus VAB plus VAB of 0 plus is equal to 0. Then VAB of 0 plus is VAB of 0 plus is equal to minus 10 volts. 20 minus 30, okay, minus 10 volts. Next, this is also computed. Okay. Now, next we have to find Ix of infinity. Ix of t is equal to infinity. Ix of t is equal to infinity means a t is equal to infinity. What will be the circuit? A t is equal to infinity. A t is equal to, sorry, a t is equal to infinity. What will be the circuit? Circuit would be like this. This is open. This is 10. This is 6. And this will be 5. Inductor acts as short circuit. If t is equal to infinity, inductor acts as short circuit. Steady state occurs, because steady state occurs at t equal to infinity. Okay, so the current flowing through this would be I of infinity. Okay, Ix of infinity. Ix of infinity is equal to IL of infinity. Ix of infinity. Ix of infinity is equal to Ix of infinity is equal to IL of infinity. Okay, so the current flowing through this is, okay, 20 volts is applied across this. Okay, IL of infinity is equal to IL of infinity is equal to 20 by 5 is equal to 4 amps. 4 amps. Next, we have to find Ix of t for t greater than 0. For t greater than 0, what will be the circuit? For t greater than 0, the circuit would be like this. Volts, 5 ohms, 10 ohms, 10 ohms, 6 ohms, 5 ohms. This is 100 left. Okay, the current which is going to be I of t for t greater than 0. Okay, so I of t for t greater than 0, either you use that formula, I of infinity plus I of 0 minus I of infinity e power minus t by tau is for what? For t greater than or equal to 0. Okay, you know what is I of infinity? I of infinity is 4, I think. Plus what is I of 0? 6, I think. 6 minus 4. Okay, e power minus r by l into t. Okay, let us find tau. Tau for t greater than 0. Tau for t greater than 0. Tau for t greater than 0. What is tau for t greater than 0? Tau means tau is equal to what? Tau is equal to L by RTH. RTH. L by RTH. RTH is the resistance between the terminals of the inductor. Between the terminals of the inductor. Okay, so what will be RTH? Okay, how can you find RTH? Okay, in order to find RTH, I have to make all sources 0. When I make that voltage source is replaced by short circuit, then this will be 16 ohm, and this will be 5, and inductor 1 Henry. Means what is RTH now? RTH is equal to 5 ohm only, because it is right. Okay, so RTH is equal to, this is 1, whereas this is 5. Okay, you put this in here. Okay, you get 4 plus 2 into e power minus 5. Okay, you can also use that formula. I of t is equal to any, total complete solution. Complete solution for non-homogeneous differential equation is composed of two solutions. One is complementary function a1 into e power minus t by tau, and steady state solution. Okay, this is what a. Okay, this is equal to a1 e power minus t by tau plus I of infinity. You know the value of I of infinity. So this is I of t. You put the value of I of infinity. I of infinity. What is I of infinity? I of infinity is 6. This is I. Okay. Now you use initial values. Initial value I of 0 is equal to, use initial condition a1 plus 6. Initial value is 4 is equal to a1 plus 6. Sorry, its initial value is 6. Initial value is 6, whereas its final value is 4. Final value is 4. Final value is 4. Okay, from this you get a1 is equal to 2. Okay, you substitute the value of a1 and you have to find tau. Tau is equal to L by RTH. Then you get the same expression I of t for t greater than or equal to